French philosopher Pierre Duhem, in a short but very illuminating book which was written at the start of the 20th century called To Save the Phenomena, reconstructs the history of a physical theory from Plato to Galileo. And in that book, Duhem captures very well the spirit of ancient Greek astronomy as that of saving the phenomena. So there are lots of quotes from, for instance, Simplicius' commentary to Aristotle de Cielo that nicely captures this idea that the aim of science, the aim of ancient Greek astronomy, was not really to tell us a true story about planetary motion, but to provide us with a system of hypotheses that could save the appearances.
Here, the red lines are the apparent positions, as seen by the Earth, as they appear to us. Ptolemy made a second adjustment to the deferent. He split the center in two. There would now be two centers, a center of distances and a center of motion. The planet, or rather the center of the planet's epicycle, would move in the shape of a circle around the center of distances, but its speed would be determined by moving at a constant angular rate around the center of motion. This center of motion was called the equant. The angles of the blue lines from the equant remain 45 degrees apart, but the planetary positions change as the white circle they are on moves, which then changes where they appear to be as the Earth watches them. Let's watch the transitions again, from a simple circle, a concentric, to an off-center circle, an eccentric, to the use of an equant. With this model, a planet moving on an epicycle, on a circle that doesn't have the Earth at the center, moving at a constant speed as perceived by yet another point, the equant, Ptolemy decided that his job was done. Copernicus rejected the uneven motion created by Ptolemy's equant and instead used two epicycles per planet. But the effect of two epicycles versus the equant is observationally identical. Here is a Ptolemaic representation of Mars, with the epicycle removed, to compare with the Copernican system with two epicycles. As I fade back and forth, the position of Mars barely changes, and the direction it would be perceived in from the center changes even less. The difference is less than a minute, and is therefore observationally indistinguishable. In fact, Copernicans would often use the equant instead of the double epicycle when doing their calculations, because the math is easier.
from a philosophical point of view, what matters for our purpose here is the fact that Galileo defended what Pierre Douin calls the method of the physicist against the method of the astronomers. He was the first one that dared to say that the aim of science is not to save the phenomena, but to provide us with a true story about the phenomena.